on there. So X is going to be persons on the bus in this category. With it? Okay. So, now, what is my revenue from this? X times the ticket price. This is the ticket price, and that's how many people are going to do it. So this is my revenue. Okay? And we have had that kind of a problem before. So that's the revenue. What is it? What's expense?
Can't you just, why would it be 25x? Because
If you read it carefully, every extra person you have, guys, please stay focused, because we've got a lot of work to do. If you had,
because it's $30 per person, and you minus 25 cents for each ticket.
no, yeah, each ticket you sell. So if you've got 10 persons, then your ticket won't cost 30 bucks anymore. If you have a whole bus load, it's going to be a lot less. That's what he's saying. The more tickets you sell, the less it's going to be to get on that bus and take the tour. Okay? So that's why it's this. Okay, now what's my profit? Oh, by the way, what's my cost? 200 bucks. See? So it's really a nice straightforward question. This is going to be equal to X times 30 minus 0.25X, what? Minus 200. And there you go. Go do it. Okay? And don't forget to do the second derivative. It's only a second degree equation. It slopes down, right? Because of that one. So it's that little parabola. It's going to be a maximum, but you better do a check so you get that. Okay? So that's the way it goes. Any other questions on this one? Any questions on your assignment? Okay, got that done. Oh, that's fast. Yes?
Can you do 31?
31. Okay, I did that one the other day.
Yeah.
Okay, let's see. I'm going to hold on it. And let's check to see if we have it on Monday yet. Okay? And we probably should take a little time on Monday, but we have the strings people out on Monday. You're not one of the strings people. Okay. So, does anybody have any questions on 19? Okay. I will give you some quick ones there. And we have a circle. Actually, we have a semicircle. And here's the center of it. And these points are generated by x squared plus y squared equals 25. You're just supposed to know that. Okay? And so that's going to give me all the points. And over here, I have a point which is x comma y. You with me? Okay? Now, so that's that point, but there's not going to, also in here, that's going to be a negative here, and we're going to put this rectangle in here. Okay? With that in here, from here to here, how far is it? That's the x here. So that's going to be x. But there's another x over here, right? Now you might say that's a negative x, but we're talking about distance. So this length of it is 2x. Okay? How high is this? Okay, times y, and that's going to be area, and what are we looking for? Maximizing. Okay? And now we just turn the crank and pop it out. Now these two problems, 19 and 31, have a lot in common in terms of how they develop. Okay? Before you see here, you're going to get y squared equals 25 minus x squared. And you take the square root of it, like that, and you have y. Okay? Are we taking the negative values? No. These are lengths. So it's going to be the positive value. Okay? And so you're going to have this in here, and you're going to have something that looks very much like the other one. Anybody got this far and got stuck yet? Yeah?
I had trouble finding the derivative just because it was like product rule with the chain.
Oh no, it's not that difficult. Okay, I have a couple minutes, so let's just dump it in here. So the area is going to be equal to 2x times, are you with me on this? Any questions of this? Okay, now I'm gonna take the first derivative. Shall we take the derivative of the first times the second? The derivative of that is going to be 2. And then I'm gonna have here 25x squared to the 1/2 plus, okay? Then we'll take the first, that's this, times the derivative of that, which is 1/2 times 25 minus x squared to the negative 1/2 times what? Negative 2x. Okay? Now these cancel each other out, just to make that simpler. And this is, I'm going to write it in different form because it's a little easier for you to see. This gives me 2 times the square root of 25 minus x squared. And this get, oopsie, we'll go minus 2x, that's all right, yeah. Minus 2x squared times all over the square root of 25 minus x squared.
So
Right?
So the bottom part isn't under the bottom part either?
Pardon? No, this is just on this part.
Okay.
Okay? Now, we want this to equal 0. Now, what's the common denominator? Well, the common denominator is this. 2 times 25 minus x squared minus 2x squared all over the square root of 25 minus x squared. For you see, if you want to get a common denominator here like this, over here, we're going to do the color here so you see it. This is 25 minus x squared, square root of, and then this here quantity here is going to be squared. Because I added it to the bottom, I have to add it to the top. And that's how you get out of these jams. Okay? Now, the top becomes nothing more than 50 minus 2x squared minus 2x squared. Questions at this point? Shall I stop? No, because it's so, I don't really want to stop because it's so easy after this. Okay? What does this have to equal?
0.
Okay, there's 0. Okay? And this is going to be 50 minus 4x squared, like this, equals 0, or 4x squared equals 50. Put this on the other side of the equation. So this implies that x squared equals 50 over 4. And I think I'm just going to leave it there. And so x is equal to 2, and the top is the square root of 50, which is equal to 5 times the square root of 2 over 2. Are you with me? Yes.
What happened to the denominator?
This denominator?
Square root of 25 minus x squared.
Now, some of you did a problem this way. You cancel here, so you have 25 over 2.
She's talking about the
Up top.
Okay, I will go there in a minute. Let me just do this one in a minute, and then I'll go back to it. So this is the square root of 5 over, oh no, it's 5. This is 5 over the square root of 2. And these two quantities are the same. And those are the correct answers, but we're not quite finished with the problem. Now, I didn't follow you. Bethany,
Okay,
are we here?
yeah.
Okay. How did we go from here to here? I should put an imply because I don't have the denominator. This is this here on this other side here. These two are equivalent. Because see here, this times this is 50 minus 2 times that's this.
Yeah, but did you just get rid of the denominator?
I just ignored it.
Why can you do that?
Okay. Now, why can I do that? Number one, I should be careful that x is not equal to 5. Then we'd be in trouble down here, okay? But now, if you have, okay, let's do it this way. I can cross multiply. Shouldn't have done this like this. This is 0 over, we'll just make it 0 over 1. It's still 0. Give me 0 over anything, but not 0. Okay, so this times 0 is 0, and this times this is just, so you see it? Okay, and so you still have it equals 0. This is equal to 0, so that's why. Clear as can be. That's how you do a lot of these. That's why we wanted to do, I got a couple of them. Okay, so there you are. Okay, now, the next thing we want to do. We can spend a little more time on this assignment. If we had a block period next week, we'd probably look at a rainbow, or we would look at blood vessels in terms of this section. And we would kind of do it together, because we are fearfully and wonderfully made dealing with blood vessels. And what is the optimum least resistance in terms of a major artery going to secondary arteries? And the other one is a rainbow. Well, I don't know if we're going to do that one either yet. That one deals with the angles involved and dealing with calculus also, and how they're designed. Okay, now we've got about 10 minutes, 15 minutes to introduce this next section. This optimum one we did, make certain you spend some more time with it. This next one isn't all that difficult, but I would like to have you read something to start with. It's almost a disclaimer. Will you go to page 270? 270. 207. And I'm going to have somebody read this. 270. Okay? Where it says in example 1 and 2, what we're doing here is approximating. Okay? In education today, we're doing more and more approximating, mainly because we want to know if the answer we get out of our calculator or computer makes sense. That's why you estimate. Does the answer make sense, or is this ridiculous? Okay? And so, Lucas, would you read where it says, in example 1 and 2, we use calculators to check. Just read that paragraph and then we'll talk about it.
In example 1 and 2, we used a calculator to check the accuracy of our approximations. This begs the question, why bother with linear approximation when a calculator does a better job?
Oh, just a second. Did you get that nice little statement? Just like we think the world do this for? Continue.
There are some good answers to that question.
Continue.
Linear approximation is actually just the first step in the larger process of polynomial approximation. While linear approximation does a decent job of estimating functions' values when x is near a, we can generally do better with higher degree polynomials. These ideas are explored further in chapter 9.
Okay, now, so, only reason for doing this here, even though it doesn't help us a lot, is to get us ready to look at the process. And what is that process we're talking about? Go to page 620. 620. 620. And at that point, those of you who take Calc 2, this is Taylor series. You're going to be sweating at this point. But there's some absolutely wonderful things come out. Okay. This is how, and some of this stuff is how the calculator does its calculating. This is the inside material of giving you answers. E, for example. That one happens to be located 3 down in that table 9.5. And you notice there's an x up here, and so I'm going to make this x equal to 1. So E is equal to 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial, that kind of stuff. That's just fascinating. That will give you an approximation for E. Okay? And another one he has there is the sine. How can I get the value of the sine at x? He says, now we're going to do this, we won't get there today. I have it prepared, but I didn't do it. Is equal to just plain x for sum, but otherwise it's minus x squared over 3 factorial plus x to the 4th over 5 factorial plus, no, minus x to the 6th over 7 factorial, etc. Okay? That's what it turns out to be in terms of approximations. Then when you get over here, there are going to be 3 ways to tell how accurate you are. Now your calculator says we want to be accurate to 10 places. That's what's built into your calculator. A couple of times I can trick it so that it doesn't give us the right answer. I've shown you some of it, And there are a number of places that it'll get the wrong answer, because it's using these kinds of ideas to develop answers. That's the algorithm that makes it tick. And so that's coming, and it's kind of fascinating stuff. But now today, we're going to do one just to get a little bit of a flavor for how this works. And here it is. Let me just go to my computer here a minute. I think I've got something on, and I think we can do this. These aren't going to be terribly hard to do, I don't think. Come on here. Okay, here we go. Notice I'm doing this one. I have one up here too for you. And notice here I have y equals the square root of x. And here I have done something else. I have figured out at the point 1, 1 what the tangent line is. Okay? Let's do that just quickly a minute so you can see how, because you're going to be doing this. We're going to have here y equals x to the 1/2. See, that's right here. And I have this point, 1, 1. And so this gives me y prime, which is equal to f at x prime, equals 1/2 x to the negative 1/2, which is equal to 1 over x times the square root of x times 2. You with me on this? Got it? Okay, now you're going to be doing this kind of stuff. Okay, now I'd like this line through this point here, and so f prime at 1 equals 1/2. See that? Question? Okay, now what's this line? The line that what we're going to try to find here is going to be y minus 1 equals 1/2 times x minus 1. With me? Okay, so this gives me y equals 1/2 x minus 1/2 plus 1, which gives me 1/2 x plus 1/2. Which is equal 1/2 times x plus 1. See that? See what's there? Any questions? Now, that's all we have to do basically on some of this stuff to get started. And then we're going to, when you read this material, and what I'd like to do is at this point, Desmos really works well. I'm going to expand and expand and expand. And after we do a little bit, you're going to see that this line is going to be just about like that line. This one's going to just flatten out as I'm going along here. So let's just get started here. I want to go out this way. Now look how flat it's all in this area right here. See that? And now I did it one more time. We'll do it one more time like this. Now you see, if I would estimate, see this is exactly at 1, but if I find out my value of my function way out here, there isn't very much difference between these two lines. Okay? That's what we're going to do, is to do some evaluating. Okay? So we'll just do that a minute. Let's see, I think I can just drop this off at this point a minute, and then we'll go back to the overhead here. And let's take a look at that a minute. My function here is, lost my yellow one, or my blue one. Okay, I have this function. F at x is equal to 1/2 times x minus 1, correct? Plus 1. You see the equation over there? Okay, this is approximately equal to f at 1.1. Okay, and now your author, I think, is called this thing L, your line. Okay, so let's just dump this in here once. And so F1 like this is equal to 1/2 times 1.1 plus 1. Oh, let's talk about something else. What am I doing here anyway? What's my function? F at x equals the square root of x, right? And when I'm trying to find out what is an approximate answer to this, this is what I'm going to get. This is equal to the square root of 1.1 which is going to be approximately equal to my number right over here. Okay, and this gives me 2.1 over 2, which equals 1.05. And if you dump that in your calculator, you find out you are really, really close. Okay? Dump it in your calculator, and did I do that and write it in my, oh, I have the wrong sheet here. What does it turn out to be?
1.048.
Oh, it is 4?
48.
488, like that. Okay, so we're very close. Now, let's go further. Okay, now what is the difference between those two is the difference between the line and the curve. Is that clear to you or not? You want to see it? Or you got it? You got it? You want to see it? You got it. Okay, now, so that's what we're going to be doing.
Tanner wants to see it.
Okay. Here we go. Now, we're going to go to 1.1. Here's 1.2, right over here. Now, it's going to be the difference between those two lines there. Well, let's just go back to the basic over here. And here's 1. This doesn't show it very well. Now, notice, if I go all the way here to 2, 1.2, it'll just be plain 2. If I go to 2, there's quite a bit of difference between these two spots, okay, right here. And so the error is going to be between these two. That's what we're talking about. And so to find the value of this point on this curve, we just go to this one over here, right over here. Instead of figuring out the value, I would like the value of this, like a 2. But I go to this line and pick it up over here. Now that one is so nice given here. Let me just do that a minute. I think I can do that. We're going to find, what is f of 2?
Could be up to 4.
Yes.
So the approximation stuff only works for points like within a certain range of the.
Yes. Very close. Okay, they have to, how close? Oh, that's chapter 9. Okay? And then because this is what you're going to do. Did you hear what her question was?
Yeah.
How close? When you find out how close you want to be, then you run through a little test. There are 3 of them that are given. One is a trapezoidal, which is kind of nice, and there are a couple others. And then you can work backwards and say, hey, you have to be this close. Otherwise it doesn't work. Okay, now let's do this again. Let's see, this is going to equal 1/2.
Mr. Kramer, isn't it f of 4 not f of 2?
Is that what I'm doing?
Yeah, if you want the where it's 2.
This is 4.
Yeah.
This is 2. That's okay, but let's go to 4.
Which one did you want to do?
I wanted to do what you're talking about. That's what I was talking about too. I was off on it. Okay, so now this is equal to 5/2. Okay? Now, versus what it should be is 2. So we're half off. See exactly? Are you with me? See, this is a half off. This is 1 unit. So you're half off. That's the distance between those, what your approximation does. Okay? Okay. Now, okay. Go with me now to a couple things in your book, real quickly. Page 268. This doesn't work if you don't have a differentiable function. You with me? If you have sharp points, it doesn't work. It has to be a curve. And then he develops it, and there's the definition. There's the definition. And we did an example. Now, we'll do more dealing with your assignment. A couple things there that'll be helpful. I was hoping to go a little further. Notice in problems 7, 10, and 12, it gives you the function, and it gives you a value. Okay? See, it says you're going to use a equal to 2. That's where you're going to be close to 2. And so you're going to make it 2, and then it goes to 2.1. Are there questions on that right now? Okay, now go to 13. Looks very different. You've got to find the point and the function. Okay? Well, take a look. What do you think the function is? 13. What do you think the function is? Okay, we're stuck there. So we're going to go to 16. What do you think the function is there? Even though it's a harder problem, I think it tells you. That's 16, and this is, we have this, 203.
Is the function for 16?
Pardon?
Is the function for 16 the cube root of x?
Okay, do you hear that? That's exactly it. The function is the cubed root of x. Okay, and what do you think x, where do you think the value is that you're going to pick to get started with? Which one can you figure out? If this is going to be, A is going to be 64. Because you can figure out because the cubed root of 64 is 4. Okay? So that's how that one comes into play. So check that out. Okay, this one, what do you think it is? 1 over x. That's my function. And what do you think the value of A is? 1 over 200. Which I think is 0.05.
So a is equal to 200?
No, A is going to be this. Well, yeah, so 1 over 200. 1 over 200. Because what we're approximating is 1 over 203. But we can figure this one out quite easy.
But if the function's 1 over 203, wouldn't a be 200, not 1 over 200?
No, it's 1 over 200. Okay, so check that out. Okay, that is what we wanted to accomplish here. Work on it. We'll spend a little more time on Monday on this. Okay. Now, Greg isn't here. Because I had his name up there too. Tanner, you want to just exit for a little while?
Yeah.
Okay, I'm going to hand your test back. And I gave, again, so you can figure out what the grade is. Did anybody check last night and get a grade and check again this morning and found that it was different? Okay, if you did, it was this. If you got 40 points, and when I was finished, in fact, I got out of bed and, because I was thinking about it, after I was finished grading it, looking what happened, I wasn't satisfied. I thought some of you had worked a lot harder than what the grade reflected. And so I thought, I need to tweak this thing. So I used that square root one again, and I'll show you what I did. What I did is when you do the square root one, you need 100 underneath here for, see, if you had 50 here, you multiply by 2, and then you get 100. So I multiplied your score, your raw score by 20, took the square root of it, and then multiplied by 5.
What?
Oh, what? Okay. What did I do? So you got a 36. 36 would have been like a 72, which would have been a C minus. Okay, so I'm going to multiply by 2. Oh, no, I didn't want that one. That's not good. Let me do a different grade.
Let's do 20.
I like 20. That's good.
Yeah.
20. Failure. That's awful. Times 2. Maybe it's not much better
Don't
after.
you times by
Why would you times
by 2? Don't you?
No, I don't want that one either. I want 36, 64, a 36.
That's what you just said.
I just did that.
Do 40.
Okay, I think I've got it now. 32.
Do 40.5.
Okay, 32.
8.
Okay, and 32 is that a D? Yeah, it's just a, okay, that's a D. D plus. No, not even a D plus, just a good old D.
D.
Okay, times 2, square root of, times 5. So this is 64, square root of, times 5, which turns into 40,
40.
which is a B minus. Okay, that's the kind of stuff. Now, this one gives you the maximum kinds of things. Others, and I just did it on spreadsheet to get a number. Your grade is going to be in the blue for most of you. Some of you got 50s, so you didn't get a blue one. But most of you got blue ones. And now also, we've got Chanel. Chanel, will you go up there and give us a little talk about what you did? No, you can do it from there. We'll just talk. You talk through me, okay? Here's the problem: is the product is equal to this, okay? And I gave you this. I gave this to you, which wasn't in my original plan, but I thought maybe you would be confused if one number is double and the other one isn't, okay? So this is your objective. This is your constraint. And solve, see, she solved it very nicely. Plop it right over here is this, which is very neat. And then, okay, now don't worry about this yet. Okay, she's got this. And then I really, she just did the second derivative too while she was at it. Okay? Now, we're gonna go down like this, right over here. She sets this equal to 0. She doesn't want this done.
Oh, I wrote second derivative, but I didn't mean that.
Okay.
Yeah, that should.
Oh, okay, then you're right.
Yeah.
Okay, now we're okay. I got you. So you solve this, and this is really nice and easy to solve. This is a whole lot of work. Okay, she just multiplies, cross multiplication, gets this, and she gets a 12. Okay? The other one is going to be 24. And many of you did that and you stopped. What is it? Is it a maximum or a minimum? Okay? And so she takes the second derivative, and obviously it's going to be a minimum. Okay? Here's the second derivative. Dump anything in there, they're always positive. Okay? So it's a minimum. This is what many of you missed. Okay? Nice job. Then, I had hoped to do this one. And she ran through here, and some of you got here, picked up a 1, you forgot the minus 1. Okay? Which messed things up. And then what's so neat about this question, which I liked about it, is 0 is inconclusive, x equals 1 is your max, and minus 1 is your min. Okay? And then they're listed what they are there. Okay? Now, in problem number 2, over here, what I wanted to see, and I have Greg's here, and he could have done a number of things of developing it. He had x equals, this is the local max. Okay, local max. And I didn't count off, but I would have really liked you had your y value was equal to it. Okay? Because it's maximum at 0, 0. Okay? 0 and 0 up. And then when across here, we'll see that in a moment, local min. And he has 1 comma minus 1/2. Okay? And then we have the absolutes below. This is max, so I did keep this consistent, and that was 2, 2. And the absolute min is negative 1 comma negative 5/2. Okay? Now, you had to figure out, because I did give you the restrictions of a minus 1 to 2, like that. And so you have to do the endpoints. And this is one of the endpoints, which turns into a max. This endpoint turned into a minimum. These just were a couple of interesting things along the way. Okay? And so you have all that stuff in terms of that problem. Okay, now, we'll, you don't have to hand these back. And you take a look at what we have here.